Sir, shall I start?
Start, madam. Madam, start.
Madam, share the screen.
Yes, ma'am.
Share your screen.
Share it, ma'am. Is it okay? Hello?
No.
No, 1 second, ma'am.
Wait. It is buffering.
Okay.
Madam is connected, madam. Start.
Hello?
Madam, your screen is not there. Please share again.
1 second. Okay, ma'am. Is it okay, ma'am, now?
No, ma'am. I can't see the screen. Your screen.
Okay, 1 second, ma'am. It's okay only, ma'am. Signals. Is it okay, ma'am, now?
No.
Hello?
No, madam.
No. Okay, let me switch on to the other, this one.
Change the mobile network, madam. Or that is switch on to your mobile data or something. Change that thing.
Is it
Yes,
okay,
it's
ma'am, now?
sharing now. Buffering again. Again went off. Again. Madam, it is sharing now. Yes, your PPT.
Okay, ma'am. Is it visible?
It's balancing of reaction.
Yes, ma'am.
Okay, you go. You on teach now.
Good morning, students. Welcome back to the chemistry class. Yeah, we have already started about balancing the reactions. Yesterday, we have discussed about different types of reactions. Okay, oxidation numbers and the rules to calculate it. And we have also seen about balancing the reactions. Okay, there are two methods of balancing the reactions. Okay, the ion electron method and the oxidation number method. Yesterday we have already discussed. Let us have a quick review of it. In the oxidation number method, what we have to do is first we need to identify the elements which are undergoing a change in the oxidation state. Okay, so once we identify the elements, we need to see how much change is being done, and then we have to multiply the numbers with a suitable integer such that the number of electrons lost are is equal to the number of electrons gained. Okay, then after we multiply, we have to just adjust the coefficients. We have to multiply the whole equation, then we get the balanced equation. So oxidation number method is quite simple. So now comes the balancing of the redox reaction by ion electron method. Okay, so in this method, this also requires the same step. First we have to identify the elements which are undergoing oxidation and reduction. Okay, so once we identify the elements, we have to classify the reaction into two types, that is the oxidation half reaction and reduction half reaction. Okay, then we need to balance the elements. This is the balancing order. We have to balance the elements except hydrogen and oxygen. So that means some few of the metals like chromium, potassium, any whatever the metals are there, elements are there, those we have to balance. Then comes the balancing of oxygen, and at last we have to balance the hydrogens. So among the elements, these one. And finally, we have to balance the charge. Okay, so we will go through the example, then you will understand it better. Yeah, this already I have started yesterday, so let me again tell this, because this is a very, very important concept and a question of 4 marks is asked from this topic. So balance the equation, that is chromium trihydroxide reacting with iodate, IO3 minus, and it gives iodide and chromate. So this reaction we need to balance. So what is the first step? We have to identify the elements whose oxidation states are changing. So see here in this, we are considering chromium and chromate, iodate and iodide. So we chromium and chromate. Here it is undergoing the changes, right? So chromium is, the oxidation state of chromium is changing from +3 to +6. Okay, that means it is an increase. So increase in oxidation number is what is called as oxidation. So this change would be our oxidation half reaction. So change of chromium hydroxide to chromate is oxidation half reaction. Now let us see this one. Iodide, or IO3 minus, it is becoming I minus. So we are finding out the oxidation state of iodine in both these cases. In this case, in IO3, the oxidation state of iodine is +5. Yesterday we have seen the rule, right? Whoever we are finding, we are writing it as X, and here 3 oxygens, so 3 into -2, because each oxygen, its oxidation number is -2. Okay, and because the charge over here is minus, so we have to equate it to -1, because the rule says that the oxidation states of the elements should be equal to the charge. Suppose if it is an ion, so this is an ion, the oxidation numbers of these elements should be equal to the charge. So we are finding out the oxidation state of iodine as +5 in this case. Now here it is changing to I minus. That means the oxidation number of iodine is here -1. So the oxidation number of iodine is changing from +5 to -1. That means what? It is decreased. So the decrease in oxidation number is called as reduction. So -5 will become, sorry, +5 will become -1 when we are subtracting -6 from that. +5 -6, that gives -1. That we have to understand. Little max is required over here. Okay, +5 is becoming -1 means we have to subtract subtract 6 from 5. That then only we'll get -1. Okay. So minus is because of the electrons. The charge of the electron is negative. So actually the electrons are being transferred. That is the reason the oxidation states are changing. Yesterday I have told you, whenever there is a change in the oxidation numbers, that means it is a redox reaction. Yeah. We have classified the reaction because the oxidation states are changing. This is the oxidation reaction and this is the reduction half reaction. Then the step 2 involves balancing the atoms other than oxygen and hydrogen. So other than oxygen and hydrogen, what are the atoms? In this case, it is chromium, and in the reduction half reaction, it is iodine. So you see here, chromium is 1 over the left hand side. That is the reactant side, only 1 chromium we have. And over the product side also we have only 1 chromium. So no need to balance the chromium over here. And in the reduction half reaction, you see only 1 iodine on the reactant side and only 1 iodine on the product side. So iodines are balanced. Okay, in some of the reactions, we will not be having same number of atoms on the reactant side and product side. If it is not there, then we have to balance. Okay, so that is the second step. Yeah. Next step. The third step is about balance by adding required number of water molecules on the deficient side. So you have to understand here. You see, now we have to balance the oxygen. On the reactant side, how many are there? 3 oxygens, OH3. That means this 3 is for oxygen as well as for hydrogen. Now we are balancing only oxygen. So on the reactant side, we are having 3 oxygens, and on the product side, we are having 4 oxygens. So what we have to do? We have to add oxygen on the reactant side. So what is the method of balancing the oxygen atoms? We have to add required number of water molecules. So here we are having 1 deficient oxygen. So I'm writing 1 water molecule. Hope you have understood this. Okay. And same thing as it is, I have written the product. Next you see here for the reduction half reaction. On the reactant side, we are having 3 oxygens. On the product side, we do not have any oxygens. So what I have to do? 3 oxygens, I have to write it as 3 water molecules. Okay, 3 oxygens have to be written as 3 water molecules. So in this case, in this step, we have balanced the oxygens. Okay, now we have to balance which element? Hydrogen. So whenever balancing the hydrogen atoms, we have to see that whether the reaction is carried out in acid medium or basic medium. Okay, so this is a basic medium because we know that CrOH, OH means it is a base. Metal hydroxides are bases. That you should understand. So now how to balance the hydrogen in the basic medium? Let us see here. So what we have to do is, see, balancing the hydrogen atoms by adding required number of water molecules on the deficient side and writing the equal number of OH minus ions on the other side of the equation. Okay, for the reactions occurring in basic medium. So see, what was our final in the previous step? This was our equation. So that equation only I have written here. Okay, now you see, we have to balance hydrogens. On the reactant side, totally how many hydrogens are there? 3 plus 2. Okay, so 5 hydrogens are required on the product side. So what I will do is, I will be writing 5 water molecules on the product side. At the same time, 5 OH minus ions on the other side of the equation. What is the other side? The other side is the reactant side. Okay, this is the step. Carefully you have to understand. Okay. Same thing here. Iodate, IO3 minus. Now this is becoming I1, I minus plus 3H2. Here you see, on the product side, we are having 6 hydrogens, 3 into 2, 6 hydrogens. On the reactant side, we do not have any hydrogens. So what I have to do? I have to write 6 water molecules on the reactant side and 6 OH minus ions on the product side. Hope you have understood. Okay. To balance the hydrogens, we have to add the water molecules on the deficient side and equal number of OH minus ions on the other side of the equation. So this is the step. Yeah, next step. Step 5. Writing the number of electrons lost or gained in the oxidation and reduction half reactions respectively. So what is the oxidation reaction? Chromium hydroxide becoming chromate, right? So what is that? Let us see here. Chromium, the oxidation number of chromium is changing from +3 to +6. We have already discussed, right? So that means what? Chromium has lost 3 electrons. So I'm writing that 3 electrons in the product side because it has lost. Okay. Now what is happening to the iodine? It is accepting 6 electrons and its oxidation number is changing from +5 to -1. Okay. 6 electrons and each electron, its charge is -1. This you are learning right from your lower classes. The charge of the electron is -1. So 6 into -1, -6. So this +5 is becoming -1 because of -6. Hope you are understanding. +5 -6 becomes -1. This is about the charges. Okay. Now you see, what we have to know is 3 electrons are lost, but 3 electrons are lost by chromium, but 6 electrons are gained by iodine. So these numbers are not equal. So what we have to do? I should multiply this with this whole equation with 2. So that 3 into 2 becomes 6. 6 electrons. Okay. So this is what I am doing. You can see this into 2. So I am multiplying, becomes 2 chromium hydroxide, 2 into water, 2 water molecules, 10 OH hydroxide ions. So 2 chromiums, 2 chromates, 10 water molecules and 6 electrons. Okay. Then another step. What you have to understand here is, you can see here. Here 2 water molecules are there. On the reactant side, on the product side, 10 water molecules. So here itself you can cancel off. 2 if is removed from 10, that means it becomes 8. You can do it over here itself, or else at the final, what we have to do is we have to add these oxidation reaction and reduction half reactions. See here. Now, the last step is adding the oxidation half reaction and reduction half reaction. So we have to add these 2 reactions. Okay. While adding, what we have to do is, whichever are common ions on the reactant side and on the product side, those common things we have to cancel off. So here you see 6 electrons on the product side, 6 electrons on the reactant side. So these we have to cancel. Okay. And remaining things you check. 10 OH minus ions on the reactant side in this equation and 6 OH minus ions on the product side here. So here we have to cancel off. Okay. So 6, if you remove from 10, it becomes 4. So 4 OH minus ions. Okay. And at the same time, water also you can do here, but I'm showing it in the next step, this step. So you see 2 CrOH taken thrice plus IO3 minus plus 2 plus 6, 8 water molecules I have written here plus 4 OH minus ions. This is giving 2 CrO4 minus 2 plus I minus, and total water molecules you see 13. Now here on the reactant side we are having 8 water molecules and on the product side we are having 13 water molecules. So if you remove 8 from 13 it becomes 5. So the final equation is this. Now you can check the number of elements. On the reactant side, how many chromiums are there? 2 chromiums. Here also 2 chromiums. Oxygens, let us see. 2 into 3, 6. 6 plus 3, 9. 9 plus 4, 13. This side you check. 2 into 4, 8. 8 plus 5, 13. Yes, oxygens are balanced. Then hydrogen, let us see. 2 into 3, 6. 6 plus 4, 10. So here, where are the hydrogens? Here. 5 into 2, 10. 10 hydrogens. Next, which element is left? Iodine. So here only one iodine. Here also one iodine. Okay. So this is the entire process. How to balance the redox reaction in basic medium. Okay. Only a little care you have to take while balancing the hydrogens in basic medium. Next, let us see balancing of equation in acidic medium. This is very easy. Okay. So here the question is given as balance Cr2O7 minus 2 SO2 gives Cr plus 3 plus SO4 minus 2 sulfate. Okay. In the acidic medium we have to see. So what is the first step? The first step is we have to find out the changes in the oxidation states. So chromium's oxidation states we should check, as well as for the sulfurs we should check. Okay. So we are calculating the oxidation state of chromium in this case, as well as here. Here it is directly given plus 3. So here we are finding out the oxidation state of chromium. So we don't know the state of chromium. So what are we writing? 2x. Let it be x. So 2 chromium atoms are there. So 2x plus 7 oxygens. 7 into minus 2. Each oxygen charge is minus 2. 7 into minus 2. And this should be equated to minus 2 because this is the charge. The rule is the sum of the oxidation states of the elements should be equal to the charge. Okay. For the ion, this is the ion. So we are equating it to minus 2. So 2x minus 14 is equal to minus 2. 2x is equal to minus 2 plus 14. This 14 is coming over here. It becomes plus 14. So x is plus 6. So what is happening over here? Chromium, the oxidation state of chromium is changing from plus 6 to plus 3. That means decreasing. Okay. So the decrease in the oxidation state is called as reduction. So chromium is reduced. Okay. Next, coming to the oxidation states of sulfur. Here you see one sulfur. So let it be X. 2 oxygen atoms. So 2 into minus 2. Okay. Here it is equated to 0 because SO2 is a neutral molecule. No charge is written over SO2. Yes or not? So that is the reason We are equating it to 0. This is also one of the rule to calculate the oxidation state. What is the rule? The sum of the oxidation states for a molecule should be equal to 0. So that means if I am adding the oxidation states of sulfur and oxygen, that should be 0. Okay. So we are calculating the oxidation state of sulfur over here. So it is +4. And in this case, what? X plus 4 oxygens. So 4 into -2 is equal to -2 because this is the charge over here. Okay. X minus 8 is equal to -2. X is equal to -2 plus 8, that is +6. So what is happening to the oxidation state of sulfur? It is changing from +4 to +6. That means increasing. Okay. You have to make a note that whenever you are writing the oxidation states, you have to compulsorily mention the sign, whether it is plus or minus. Don't simply write the number. Okay. We have to compulsorily mention the sign, whether it is +4 or +6 or +1 or whatever it is. So the change is from +4 to +6. That means it is increasing. So increase in oxidation number is called as oxidation. So this is our oxidation half reaction. Okay. So we have classified the reaction into two types, that is oxidation and reduction. Now what is the second step? Balancing the atoms other than oxygen and hydrogen. So here you see Cr2O7 is there. Here on the product side we have only one chromium, but on the reactant side we are having two chromiums. So what I have to do? I should write 2 as the coefficient. Okay, these rules you have learned already in 10th class also you have seen. Without only adjust the coefficients. So here 2 chromiums are there. So what I do is I will be writing 2 as the coefficient. So it becomes 2 chromiums. Okay. And the other side you see one sulfur, here also one sulfur. So no need to balance the sulfur atoms over here. Now coming to the next step. What is the third step? Once we balance other than oxygen and hydrogen, once we balance the elements other than oxygen and hydrogen, then comes the turn of oxygen. So we have to balance the oxygen. Okay. So how to balance the oxygen? Let us see. Same thing. Balancing the oxygen atoms by writing water molecules. This is the same step as in the basic medium also. Okay. To balance oxygens, we have to write water molecules. So see here. On the reactant side, we are having 7 oxygens. On the product side, we do not have any oxygens. So what I am doing is, I am writing 7H2O. Okay, this is the change here from this equation to this one. To balance the oxygens, I have written 7 water molecules. Okay, so in the reduction half reaction, we'll see. In the other reaction, here see what is happening. 2 oxygens on the reactant side, 4 oxygens on the product side. Yes or no? So that means what? This side we are having 2 oxygens less. So what I should do? I should add 2 water molecules. So I have written 2 water molecules over here. This is the change. Okay. Hope you are understanding it. Please try to understand, concentrate. So once oxygens are balanced, then we have to balance the hydrogens. Okay. Balancing hydrogens is very easy in acidic medium. Okay. How to balance it? Let us see. Balancing the hydrogens by writing the required number of H plus ions on the deficient side. So you see, we are having totally how many hydrogens? 14 hydrogens. So what I have to do is, this side actually on the reactant side, we are not having any hydrogens. So I'm writing 14 H plus. Okay. In the oxidation reaction, let us see what it is. So 2 into 2, 4 hydrogens should be there. Okay. On the product side, we do not have anything. So what I am doing is I'm just writing 4H plus on the product side. This is the deficient side. So 4H plus is written over here. Okay. So we have balanced the element other than oxygen and hydrogen in the second step. Then we have balanced oxygen, then hydrogen. Now what? It is the turn of balancing the electrons. Okay. This other step is writing the number of electrons lost or gained in the oxidation and reduction half reactions. Okay. So chromium is, its oxidation number is changing from +6 to +3, right? That means it is gaining 3 electrons. Okay. So chromium is gaining 3 electrons. That is the change over here. I'm writing. Okay. And sulfur, the oxidation state of sulfur is changing from +4 to +6. That means what? It has lost 2 electrons. This is the change of the electrons. These electrons are lost. Now you see, 3 electrons are gained by chromium, 2 electrons are lost by sulfur. Okay, this is not equal. So what I will be doing is, I will be multiplying this reaction with 3 and the above reaction with 2, so that the number of electrons would be 6. Equal number of lost and gained electrons. So 2 into 3 is 6 and 3 into 2 would be 6 only. Okay. Now we have to add the half reactions. Okay. So how it is done, you check. Same thing. After multiplying, we'll be getting 2 chromate, 2 Cr2O7 plus 28H plus 6 electrons. This one. So we have to cancel off the terms whichever are common on the reactant and product sides. Okay, 6 electrons on the reactant side and 6 electrons on the product side. These have to be cancelled. And see about the water molecules here, 14 water molecules, and here 6 water molecules. Okay, if you remove 6 from 14, it would be 8. Okay, then see about the hydrogen ions. Here 28 hydrogen ions are there, here 12 are there. If you remove 12 from 28, 16 would be remaining. Okay, so this is the final balanced equation. Okay, so after we are getting the final balanced equation, again just to cross check whether all the atoms are exactly balanced or not. So you see here, 2 into 2, 4 chromiums are there on the reactant side. So 4 chromiums on the product side. Yes, chromium is balanced. See the oxygens, 2 into 7, 14 plus 3 into 2, 6. So it is 20. Yes or no? Now you see, 3 into 4, 12 plus 8 oxygens. So here also it is 20 oxygens. Oxygens are balanced. Now let us see the sulfur. So 3 sulfurs on the reactant side, 3 sulfurs on the product side. Okay. Next we'll check the hydrogens. 16 hydrogens on the reactant side and 16 hydrogens on the product side. 8 into 2 is 16 hydrogens. Okay. So this is about the balancing of reaction in acidic medium. Hope you have understood this. Okay. And after this topic, in the textbook, you are having another subtopic, that is redox reactions in stoichiometry. Okay, that is the deleted syllabus. That small topic is deleted for you. Okay, so this comes the end of the chapter. So now let us quickly review what all we have learned in this chapter. Okay, so we'll be going from the back. Okay, we have just now seen this, balancing the equations in acidic medium. We have discussed this. Okay, balancing of the reaction in the basic medium. So what we have to do, we have to first find out the changes in the oxidation states. classify the reaction into oxidation reaction and reduction half reaction, balance the other atoms. Okay, balance the element other than hydrogen and oxygen. Then comes the balancing of oxygen, then hydrogen, then the electrons. This is the sequence you need to know. You have to keep it in the mind. Okay. Then we have discussed about the balancing of redox reactions by oxidation number method. Okay. Here, this is very simple. We have to, same thing, we have to find out the changes in the oxidation state and simply adjust the coefficients by multiplying with a suitable integer so that the number of electrons lost are equal to the number of electrons gained. Okay. Then we have seen the types of reactions yesterday. Okay. So comproportionation reaction. So what is a comproportionation reaction? Exactly opposite to disproportionation reaction. Okay. So you check here. Hydrogen sulfide and sulfur dioxide, these two. That means here the oxidation numbers of sulfur is different. In this case, it is -2. Here it is +4. -2 and +4. These two sulfurs are combining and forming the substance having only one kind of oxidation number. That you have to see. Two different oxidation numbers are combining and forming only one oxidation number. In this way, you can remember. This is comproportionation. Okay. And disproportionation, what it is? It is nothing but same oxidation numbers only. Here you see hydrogen peroxide, H2O2, -1 only. Okay, peroxide, yesterday I told you. In the case of peroxides, the oxidation number of oxygen is -1. Okay, so here -1 is becoming, or we can say that one kind of oxidation number is becoming two different kinds of oxidation numbers. This would be better. Okay, one kind of oxidation number. What is the one kind over here? -1. -1 is becoming -2 as well as 0. Okay, so that is called as disproportionation reaction. And one more thing I would like to tell you is that the importance of hydrogen peroxide, what it is. We'll be seeing now, we will be using it as an antiseptic. Okay, whenever we get the wounds, to clean the wounds, we will be using the hydrogen peroxide. 30% of hydrogen peroxide is called as perhydrol. That is used as an antiseptic. Yeah. And we have seen the displacement reactions, right? Displacement reactions of metals as well as displacement reactions by non-metals. Okay. So this is the reactivity series of non-metals. So among the non-metals, fluorine is highly reactive. That means fluorine can displace all these elements, chlorine, oxygen, bromine, all these it can displace. Okay, this we have seen. And we have also seen the reactivity series of metals. Among the metals, potassium is highly reactive. Okay, that means what? Potassium can displace all these below metals from their compounds. Okay. So this is about the reactivity series of metals. So this also you have to learn. Okay. So we have seen about the metal displacement reactions. So if a particular metal is unable to displace, in this case we have seen no, iron cannot displace magnesium from magnesium sulfate. That means what? Iron is less reactive than magnesium. That is the reason it is unable to displace. Okay, this is about the displacement reaction. Then we have seen decomposition into two or more products. Okay, that is decomposition. Another reaction is combination. What is combination? Two reactants combine to form a single product. Okay, combination reaction is also called as composition or synthesis reaction. That you have to know. Okay, and we have seen oxidizing and reducing agents. So oxidizing agent is the one which carries out oxidation but itself undergoes reduction. This you have to have a clarity. Okay, reducing agent will carry out reduction but itself undergoes oxidation. This is the misnomer. This you have to keep it in your mind. Okay, and yesterday we have also I told you to calculate the oxidation states of few ions. Okay, B Durga from Hasanpati, she has done and again she has posted. Very good. What about others from other colleges? I don't know they are doing the work or not. If you neglect this chapter, you are only going to suffer a lot. This is very, very important chapter. Okay. So these ions I told you, or these ions as well as some molecules I gave you and asked you to find out the oxidation numbers. Yeah, these are the rules to calculate the oxidation. Okay, differences between oxidation and reduction. This can also be asked for 2 marks. So everything is important from this chapter. And we have also seen what is oxidation and reduction. Okay, now comes very important topic, that is the limiting reagents percentage yield. Okay, we have seen percentage yield. What is percentage yield? It is the ratio of the product formed to the actual theoretical yield. That means while whenever we are carrying out a reaction, first thing we know what we are going to carry out and how much we have to get the product. We will have a particular planning, right? So based on that, we have to get this much of product. That is our theory. But practically, we might get the same amount of product as predicted by the theory, or we can get lesser amount of product. Okay, so we have to calculate the percentage yield. If we know the percentage yield, we can decide the efficiency of the reaction. That means, yes, if the percentage yield is about 90 to 95%, then we can go for that particular reaction to synthesize the product. Otherwise, we have to go for the alternative method. Okay, so percentage yield will help us to know the efficiency of the reaction. Okay. Yeah, we have also seen about in amount than the actual required amount as limiting reagent. Okay, and whenever you have to first write the balanced equation, okay, then see whether the exact amounts are provided as per the stoichiometry of the reaction. Okay, so if we are provided as per the stoichiometry, okay, that means it is not a limiting reagent. If the substance is lesser than the stoichiometric requirement, that becomes the limiting reagent. So the product formation depends upon the limiting reagent. That you have to understand. Okay, why all this limiting reagent, excessive reagent? Because simply if we add and carry out the reaction, okay, the reactants may go waste. It would be waste of time, waste of resources, waste of energy. All these will occur. So we have to carry out an experiment in a pre-planned manner so as to avoid all these wastages. That is the reason why we are studying this chapter. Suppose you are taking the tablets also, you will not take so many grams. No, the doctor will prescribe you 1 mg only you have to take, or some 10 mg tablet you should take, or 500 mg. If you are taking more than that, what will happen? It would result in so many harmful reactions in our body. So in order to do that, only we are studying this chapter. Don't feel that this chapter is very boring or hectic. All this has practical applications in our life. Yeah, this is about the limiting reagent. Okay, it is the amount of the substance. Okay, it is the ratio of given weight of the substance to the molecular weight of the substance. That is what is called as 1 mole. Okay, and we have to know that 1 mole of a substance will be having weight equal to its molecular weight. Okay, and 1 mole of a gas at STP occupies 22.4 liters of volume. Okay, and 1 mole of any substance will be having Avogadro number of particles. What is Avogadro's number? Approximately we can take it as 6 into 10 power 23 particles, or exactly if we say 6.022 into 10 to the power of 23 particles. Okay, this is very important relation. Based on this, you will be getting a number of problems. Okay, so the problems would be calculation of moles and weight relation, it could be, or it could be weight and mole relation. Okay, or it could be relation between the weight and number of molecules, or problem based on volume and number of moles. Okay, or volume relationship, or it could be weight volume relationship. So whatever is given, you do not panic. You just see what is given, what is asked, what relations are asked. Okay, you should see the number of moles are given and volume is asked or not. You will see that, or moles are given, particles are asked, or weight is given, moles are asked. That you should see. Okay, 1 mole is equal to the molecular weight of the substance, equal to Avogadro number of particles, equal to 22.4 liters of volume if the substance is a gas. This relation you have to keep it in your mind, and based on that you should go learn the concept. Don't learn the formulas. If you go by formulas, so many formulas would be there and you will be totally confused what to use. So go by the concept. So this is what we have seen in the stoichiometric calculations. Okay, and a number of problems are there in the textbook. You please open the textbook, page number 185. This is your homework for today and for this chapter. Okay, page number 185, from here to page number 190, number of questions are given in the textbook. Okay, so almost all the questions are very important. So today you have to compulsorily solve the problems given in the page number 190. Page number 190, question number 71 to 82. These are very important. Okay, and page number 189, question number 61 and 62. This is about the balancing of reactions. You have to compulsorily do it. Page number 189 of your textbook, question number 61 and 62. Page number 190, question number 71 to 82. Almost all the concepts are covered here based on the stoichiometry. Okay. Again, another important concept we have seen was calculation of empirical formula. Okay, what is empirical formula? It is the simplest ratio of the elements present in a molecule. It is the simplest ratio. It is not the exact number of atoms. Okay, that you have to keep it in your mind. Whereas molecular formula, it gives us the exact number of atoms present in the molecule.
Madam.
Okay, sir. So this is the chapter, ma. You please go through this. So with this, the chapter is done. Please solve the problems given at the end of the textbook. Please do the work as quickly as possible. Do not keep it pending.